All right, so we can also graph inequalities on our calculator. And so this shows the graph for y is greater than or equal to x minus 2, and the shaded region is basically our solution. Now, it's sometimes hard to tell on the graphing calculator if that line is actually included or not, and so that's kind of sometimes the issue. You might not be able to determine depending on your calculator if that's a dotted line or not. And what you actually have to do is you have to tell it to graph the greater than or equal to. And so that's kind of what this says here. And the same thing for the y is less than. We've typed it in appropriately, but sometimes it's hard to tell, is it just a bad, line, or is it actually a dotted line? And so sometimes calculators, it's hard to tell when you're doing that. And so you can't always go by what you're seeing, because sometimes that would be a solid line, but because the way the calculator screen shows, you might not actually see that. So be careful when you're doing calculators on what it is. You actually really just have to look and see, okay, the less than means it's a dotted line, and then over here, greater than or equal to, that means it's going to be a solid line. So you really have to take that into consideration when you're using calculators to do these. All right, so theorem one, graphs of linear inequalities. The graphs of linear inequalities say we have ax plus by is less than our c, or ax plus by is greater than c. So if b is not equal to 0, is either the upper half of a plane or the lower half of the plane, but not both. And it determined by the line, basically ax plus by is equal to our c. So really, we're going to be doing that as far as how that goes. And so if b is equal to 0 and a is not equal to 0, then the graph is actually going to be ax is less than c, or ax is greater than c. And it's going to be either the left half of the plane or the right half of the plane, but not both. And it's determined again by the line ax equals c. So these are kind of some interesting things to note, where b is not equal to 0, and then also when b is equal to 0, but a is not equal to 0. So you have a couple things to think about. Now, so basically your first step is to graph your line, okay? And it's going to be a dashed line if the equality is not included in the original statement, or a solid line if it is. So again, it all comes down to, is it, greater than or equal to, or greater than or less than, or less than or equal to, or greater than or equal to. These are solid, these are dashed. Step two, we're going to choose a test point anywhere in the plane, not on the line. And the origin is usually kind of requires the least computations, because you plug in a 0 for x and a 0 for y, and that really tells you. But sometimes that's not going to help you, because that actually might be on the line. So that's one that's a good one to start with, but it doesn't always work, because if it's on the line, it's not going to help us. And then step three, does the test point satisfy the original inequality? If so, then you shade the half plane that contains that test point, and if not, shade the opposite half of the plane. But again, a lot of times when you're reading this, if you've solved it and you've got basically y is less than 2x minus 3, then wherever your 2x minus 3 is, so it's going to be here, and it's a positive, so it's going to be something like that. If it's going to be, well, actually, let's make it less than or equal to, so I can have that solid line, since that's what I drew. It's going to be below. And if I had the greater than that instead, so maybe I can have that, it's going to be everything above. Again, the difference between a dotted line and the solid line, okay? All right, so let's start with this one. Graph 2x minus 3y is less than or equal to 6. So step one, we're going to graph this equation as a solid line, because we have that less than or equal to. And when we do that, we get this line here. Now, next step is to select a point above or below. Okay, so since 0, 0 is actually above it, let's use that one, because that's going to require the least computation, because you plug in 0 and 0 and you get 6. Now, is 6 less than or equal to 6? Yeah, it is. And so that's a true statement. So that means the half plane that's up here is going to be in the solution set, and so therefore we shade that part of the plane. And again, we drew that solid line because it was the less than, or yeah, the less than or equal to the 6 here. Okay, so this is going to be the solution to this problem. What about if we wanted to graph y is greater than a negative 3? Well, we're going to graph y is equal to negative 3, but it's going to be a dashed line, okay? Because again, we don't have that equals to, so that's going to be where it is. Now, again, what we're going to do, we're going to choose the test point 0, 0, and we substitute that in and see what we get. Well, is 0, because there's no x's, is 0 greater than negative 3? No, it's not. And so that means this region is not going to be the case. And wait, 0 is greater than negative 3. Sorry, what am I talking about? 0 is greater than negative 3. I was thinking positive 3, sorry. And so it will be in that region. And so we have everything above here. Okay. All right, so that's going to be how we do that. And then again, another thing, just logically think on this one, if it's greater than negative 3, if it's greater than, it has to be above it. And so then automatically we would think about that one. And on this one over here, uh, this one, probably what I would do is I would solve it for y, and then whatever that is, in this case, it's going to be greater than or equal to, and we'll have something, and so it's going to be above. And so, if you go ahead and solve it for y, usually that's going to get you a solution pretty easy. And then you can choose a point afterwards to make sure you chose the right side of the which plane is the correct one for the answer here. All right. So let's stop there and we'll come back for some more.